Hello everyone. Today I'm excited to present our group project e-diabetes detection using decision tree. This project combines the power of machine learning with healthcare to tackle one of the world's growing health challenges, diabetes. So our group has three members, include Phan Van Thien-2101140068 and me, Minh. So let's look about the table of content. The first one is reason for choosing this project. The second one is practical application in real life. Next is technologies used. The next part is software operation process, additional information, and the last part is conclusion. So let's move to the first part. So the reason why we're choosing this project is diabetes has become a significant global health challenge, with millions of people being diagnosed each year. The disease not only affects the quality of life, but also places a heavy burden on healthcare systems worldwide. Addressing this issue requires innovative solutions that are both effective and widely accessible. You can see the picture below. The incidence of diabetes in humans increases as people get older, regardless of whether they are male or female. Early detection of diabetes plays a crucial role in preventing complications and improving patient outcomes. By identifying at-risk individuals through predictive models, healthcare providers can take timely action, implement implement lifestyle interventions, and reduce the long-term impact of the disease. And machine learning has emerged as a game-changing tool in healthcare, providing data-driven solutions to complex problems. With advancement in technology, even relatively simple models like decision tree can now be applied to make significant contributions in medical diagnostics, include diabetes detection. So decision trees are particularly appealing due to their simplicity and interpretability. They provide clear and logical decision-making paths, making them ideal for both medical practitioners and patients to understand and trust, despite being easy to implement. Decision trees are powerful enough to classify data accurately and effectively. Decision tree can be easily visualized in a tree-like plot that makes it even easier to understand and interpret the model. Have a look at this simplified decision tree below. We can actually take a single data point and trace the path it would take to reach the final prediction for it. So this project serves as a valuable educational experience by bridging two important domains, medical diagnostics and machine learning. It allows for a deeper understanding of how predictive models can be used to analyze health data and support clinical decision-making, making it an excellent learning opportunity for anyone interested in this field. So the second part is practical application in real life. In primary healthcare screening, the diabetes detection model can be utilized in initial health screening programs at healthcare facilities by analyzing basic health indicators. The system quickly identifies highly risk individuals, gearing them toward more specialized tests or medical consultation. In hospitals and clinics, this system can assist in evaluating patient risk of diabetes, helping doctors prioritize and optimize treatment plans based on individual risk level. Predictive predictive model like this one can help prediction this one also connect precision model like this one can serve as valuable tool in community healthcare program, monitoring and issuing early warning to prevent diabetes. This is particularly important in regions with high prevalence rate and limited healthcare resources. This the decision tree model aids healthcare professionals in making fast and accurate decisions on patient data. It serves as support tool providing critical insight to complement diagnosis and medical advice. This system can also be integrated into personal health monitoring apps, allowing users to self-assess their diabetes risk based on daily health metrics. This promotes preventive awareness and encourages healthy lifestyle choices. So the next part, Tien represented.
Okay, now we move on. Technologies used. In this part, we have two subsections. Subsection A, programming language and libraries. With Python's that's the main programming language. Pandas for data manipulation. Sklearn for machine learning implementation. Gravis and PyDot Plus for visualization. And here we have some key components. Decision tree classifier, forms learn, chain test split functionality, matrix module for accuracy evaluation, visualization tools for tree representation. Okay, now we move on software operation process. We have three main process. The first one is data preparation. Load the primer Indians libraries datasets. We select seven core features here: pregnancies, insulin, BMI, age, glucose, blood pressure, peri. Select the next one is model development. We split data into two parts: 70% for training and 30% for testing. Initial module creation and training, module optimization with entropy criterion, maximum depth, maximum depth limitation to 3 levels, and the final main process is evaluation process. In this process, we implement accuracy measurement, visual representation of decision tree, and performance analysis. Now Hưng will continue our present.
The find additional information. A model improvements. Applying entropy criterion. Use the entropy criteria to determine the amount of information gained at exploit. This approach enhances classification performance by selecting optimal splitting points, reducing uncertainty in the data. The depth limitation for better generation limited the depth of decision trees to prevent overfitting, where the model overlearns specific details from the training data. The benefits improves prediction accuracy on unseen data while reducing the complexity of the tree. And the last is comparisons of accuracy before and after optimization measured model performance before and after applying the improvements to quantify the impact. Metrics evaluated using indicators such as accuracy, F1 score, and AUC for a comprehensive analysis of the trends. And the next is B visualization benefits, clear representation of decision paths. Decision tree diagrams provide an overview of how decisions are made from input features to final predictions. Benefits allows easy verification and interpretation of each step in the decision making process, easy interpretation of decision rules. The decision rules are clearly presented, enabling non-technical users to understand the model without delving into algorithms. Application ideal for presentation, reporting, or explaining the model to clients and colleagues. Visual tools for understanding feature importance. Feature importance charts visually highlight the factors that have the most significant impact on model prediction. And the next is C feature enhancement. Feature importance analysis conduct deeper research into key features to identify those with the greatest influence on prediction results. Cross-validation implementation apply cross-validation techniques to assess model performance across multiple datasets. Benefits ensure the model is not overly dependent on a specific dataset, enhancing its generalization capabilities and hyperparameter tuning. Fine-tune critical parameters such as splitting criteria, maximum tree depth, and minimum sample size to optimize performance and integration with real-time data. Connect the model to real-time data sources to support rapid and accurate prediction in dynamic scenarios. Application, early warning system, and instant decision making in fields like finance, healthcare, and logistics. And the last a conclusion. The summary of achievement enhanced split criteria, implemented the entropy criteria to optimize decision tree splits, minimizing uncertainty in classification tasks, and improved generation, limit the tree depth to prevent overfitting and ensure the model learned generate pattern, effective visualization, and interpretability, created clear decision tree diagrams highlighting paths and outcomes, develop feature importance visualizations to pinpoint which factors contribute most of prediction, and performance evaluation conducted through compre- compress- comparison of pre and post optimization metrics such as accuracy, F1 score, recall, and the next in model performance highlight overall performance. The model achieves an accuracy of X% on the training set and Y% on the test set. Insert specific numbers. Reduce the performance gap between training and test datasets, indicating minimized overfitting, faster prediction times, limiting tree depth, and reducing the number of branches, lowered model complexity, leading to quicker decision making in real time scenarios. Feature important analysis. Key feature example A, B, C contribute 8% to the model's decision making, and the cross validation results uh, achieved consistent performance across multiple validation first, provide, providing the robustness and generalization capabilities of the model. The next is potential improvements, hyperparameter optimization. Utilize advanced techniques like grip search or Bayesian optimization to fine-tune key parameters such as splitting stereo, maximum tree depth, and minimize sample per leaf node. Expected outcome addressed an additional 8% improvement in accuracy, enhanced data pre-process, remove irrelevant features, and handle missing values effectively, normalize datasets to mitigate the impact of features with varying scales, adoption of ensemble methods combine decision tree into ensemble models such as random forest, gradient posting, testing on diverse datasets, validate the models on datasets from various domains to test its flexibility and adaptability. As last, reward implementation possibilities. Dynamic decision making in finance application, credit scoring and fraud detection, and healthcare diagnostic application predict disease based on patent data such as symptoms and lab test results. The benefits is shorten diagnosis time and reduce human error in clinical decision making. Marketing optimization. The application is segment customer based on behavior and preferences. Example, target high potential customer groups with personalized campaigns putting conversion rates predictive maintenance in industries. The application analyzes sensor data to predict equipment failures. The benefits is reduce maintenance costs and prevent catast- catastrophic fa- failure. Integration in with time data in logistics use the model to forecast delivery times and detect potential disruption in supply chain, and educational tools leverage decision tree visualization as an educational result to explain machine learning concept to student and non-technical audience. And this is the